Hello everyone, this is the JS Monthly, our July meetup at lunchtime. It's 1 o'clock in UK, and today we have another meetup. Before we start our meetup with our special guest, I'm going to take you through. My name is Aris Markogiannakis. You can find me on Twitter at arismarko. I'm organizing JS Monthly, and also I'm organizing CityJS conference. We're always looking for new people. So if you want to help the community, we're a community meetup. You can email us at jsmonthly@gmail.com. You can involve, help us, and help the community. Have a special announcement today. We're going to be doing the first outdoor and in-person event in London. It's going to be happening at the Beach Bar next to Thames in London on the 17th of September. There are only 70 tickets available at the moment. So grab yours and come and join us in September. I will now pass you to a special guest, Thanos Polychronakis. He's quite well known for his community contribution, and he's going to be talking about why logging is important. We're going to have a Q&A after the talk. And for any questions, you can post them on Twitter and also on our YouTube, on the YouTube feed. Thank you very much. Enjoy.
Hello, everyone. My name is Thanos. I'm very happy to be here with you. One moment to share my screen, and we can get started right away. So, Aris, can you see my share screen?
Yes, I can.
Right, cool. So today we'll talk about why logging is important and how Logality can help you with that. Logality is a logging library that I've built, and we will see what it can do and how it compares to other popular libraries on the Node.js ecosystem. So before we get started, a few things about me. I've published nearly 50 packages on NPM. I've got over 200 open source repositories, and I have contributions on major and small open source projects like Mongoose, Sequelize, Socket.io, and a few smaller ones. So I'm quite passionate about open source, and I've been doing that for over 10 years now. It's been a couple of years that I consider myself semi-retired, and I've focused on gardening. And quite recently, I have developed a key interest on decentralized finance, which is an entire subject, a different subject entirely. So let's see what we're going to talk about today. Today, we're going to see why logging is important. What are the logging requirements? So as you are required to set up logging on your system or your infrastructure, what the requirements should be, what and how to log, and where and when to log. And then we're going to have a quick pass through on Logality and how it compares to other libraries. So this is quite straightforward. Logging is important because having a log in the right place at the right time and with the right kind of information can really save you from hours of frustration, troubleshooting, and most likely save your your live production system from burning down and staying and having downtime for hours and having a very bad day. So let's break this down. What logging helps you with? It helps you with naturally debugging as you're developing, error tracing while on production, and local development as well. Performance troubleshooting. I wouldn't say that logging excels at performance, but it can give you hints if you have the correct logs at the right place as to whether you have bottlenecks in your system. Accounting is the act of monitoring everything that happens on your system, everything that changes, every change on your system. And audit trail. Audit trail is accounting when you store it on an immutable data store, and we're going to see in depth what we mean by that later down on another slide. And security. So logging helps you with security, as naturally you would log suspicious events and attempt breaches. Now, let's start with the requirements. And those requirements really kind of apply to all all sizes, whether you start with a single instance on a single server, or you have a big infrastructure. The natural outcome of your application as it grows is that you're going to have multiple instances and probably multiple operating systems and multiple stacks. So those requirements are kind of across all of the sizes of your infrastructure. So first off, one of the requirements is that you need to take under account that multiple instances of your application are going to be running. So this is about scaling, horizontally your application. Your application will have multiple workers, which are going to work on the back end and perform, more arduous tasks and things that need to happen in the background. You will probably have multiple stacks and runtimes. So, might have a server that runs on Go, another server that does something in Java, and you're going to have, basically a multi-stack environment. And it's most likely that you're going to be using multiple services and databases like, Postgres, NoSQL database, Redis, all sorts of things. And it's quite likely that if you grow enough, you're going to run on multiple platforms, that is multiple providers. Like you might be in between the migration from AWS to Google Cloud, or you might have some service running on Azure to satisfy a certain customer. All things can happen. So that also needs to be taken under account. Now, when you are thinking about how you're going to consume your logs, you need to consider the following requirements as well, which is it makes sense to have a common logging aggregator. So you won't need to hop between systems to view your logs, right? You would expect that all of the infrastructure, all of the systems across your infrastructure log to one single system and where you can view the logs. And it would make sense for that aggregator to be queryable. And while most aggregators are basically text search engines, it would be way more convenient to have your logs in a JSON format so that you have a specific schema that you can query against, okay? I don't believe I need to go more in depth about why this is important. And you need to have a common logging schema. And so this is very important, and that's why I want to repeat it. And it makes a whole lot of sense for all of the applications, no matter what stack they're on, to use the same properties when they're referring to a timestamp, okay? So you would be able to query easily based on this timestamp or based on a log level. And, every system wouldn't have its own different log level system or different schema of logging things, and you would be forced to jump through hoops to be able to interpret logs between different systems. So having a common logging schema is of paramount importance. Let's now see what and how to log. And let's start with the what. And we start with the who am I. And the who am I is going to be explained like, who am I? Am I a Node.js application? What instance am I running? What worker am I? Where am I is, where am I running? On what server exactly? What data center? And what am I? What is my performance? What is my function? Metadata and flags and tagging. So this is actually the meat of the logging message, which is, okay, we've covered the basics. Who am I? Where am I? What am I? Now let's give you the actual data that I want to log. This is what we call metadata. And flags and tagging, we're going to see later on what we mean by that. It is basically creating Boolean tags and flags to easily being able to filter and query for the logs that you care about. So let's see what we mean by who am I. Who am I means, what's my runtime? Is it Node? Is it Go? Is it PHP? The host name that I'm running on, the exact host name, my process ID, what is my process name? How was the application launched? Was it npm start or node dot or node app / start, whatever? How did this came to be? Where and what am I? And this has to do about logging level, the severity. Is it an info message, or is it a warning, or is it a fatal message that brings the service down? What module was the log, did the log originate from? And that is what file in particular produced that log, and more specifically, what function in that file produced that log. And this is important. So when you're trying to debug your application and you see an error, you don't need to go search across your entire code base to find where this log got produced from. You have this information right there and then, and you can directly go to that file and do what you have to do. It goes without saying that we need a timestamp. Now, flags and tagging. Flags and tagging is nothing else other than having Boolean flags, basically, that create tags for your log messages. And you might tag a log message as being security related. So, you have a failed login or something that is really, you should raise your awareness around security. You tag that log message with a security equals true flag. Equally, when it's an error condition, you have an error Boolean, so you can easily query for that. And similarly, an audit. And we're going to see more examples about an audit later. Let's go into the how to log. Pretty straightforward. You need to have the ability to pretty print. Pretty printing is the act of having the logs pretty printed in a human readable manner. So this is a human readable log. You can see the date here. You can see the log level. You can see where the log came from. It's from this particular file. And the log message itself, booting services. And when you're on production, you need this to be outputted as a JSON. So this is the same log message when it's being echoed on production, which we can see it has way richer information, like all the things we talked about: host name, process ID, the process name, and all other stuff that you may want to attach. And when you're testing, you would expect that all of your tests are passing on your continuous integration machine. So you would basically mute your logs so they won't produce huge artifacts. And in case something breaks and you want to debug it, then you can manually enable tests for CI. But typically from experience, it doesn't need to happen that often. So let's talk about where and when to log. And it makes sense to start logging logs on your application boot up. And that means that, as your application starts to bootstrap itself, you create the first log should state, who am I, where am I, node environments, operating system I'm running on, what user am I running on. That's important. So for instance, you don't want your application running as root, and you want to make sure that your application is running as a specific user. So you log that, and you know that that's the case. Modules and services booting up. So basically, as your application bootstraps and starts to connect to services before it becomes ready, log all of those steps. It's one by one. So, I'm connecting to Postgres, I'm connecting to Redis, I am connecting to XYZ API, and I am warming up the cache whatever you do as steps of bringing your application in a ready state, log them, each one of them. So when something breaks, it's easy to understand, at what point your application broke and how to fix it, and you know exactly where to go. Error handlers. So there are global error handlers on Node.js that you can capture, like uncaught exception or uncaught promise rejection. When the application goes down, sig in, sig term, all of that stuff, put a log there. Listen for those events and put a log there. You have an HTTP server, whatever that is. There is a certain global error handler for the HTTP server. Log that as well, so you know what's happening there. And throughout your code base, wherever you have, try-catch statements, naturally all of those need to log. And typically they shouldn't bubble up, because you would, best practice is to handle the log on the spot. And part of handling the log, handling the error is logging it, is what I meant to say. Accounting, audit, and security. So what else do you log throughout your application's lifetime? All mutating operations. Any operation that basically writes on your database, mutates the state, like update a user profile, save a different email, create a new product, whatever the business logic of your application is. Whenever the state changes, whenever you have a write in the database, log that. This user did this change at that time, previous value, new value, depending on the use case, you want to log more or less. And this accounting becomes an audit trail when it is saved on an immutable store. And what's an immutable store? Well, again, it's up to you to figure what this is. But for instance, a simple example would be to have an S3 bucket that has only write permissions, does not have update or delete, and then automatically that becomes kind of an audit trail, because the store now is immutable. But all of this is going to be dictated based on your InfoSec policies, and your mileage may vary. I'm coming from a highly security-aware business, and that is the reason why I created Logality. That's the reason why I dived so much deep into logging, and this is important for security-aware applications. And when you're in that kind of regime, it might be required that you also log the reads. So, this user accessed this information. That might also be important for your compliance requirements. And naturally, to easily capture what needs to go where, like what needs to become an audit trail and what pertains to security, the flags help. We talked about the Boolean flags before. Now, one thing to be aware of is personal identifiable information, and considering European and California's privacy laws, and considering the fact that it's most likely the case that your logs are going to be aggregated on a third party, like Logality or something else, and you cannot guarantee, the safety of those logs, or the retention, or the fact that they remain on sovereign land, like the data remains in Europe and doesn't travel across continents. So if you're not sure, tokenize the data, basically. So convert emails, IPs, and names into a hash, an MD5 string, and work like that. So that was the theory. Now let's go into the logging applications, and let's start with a deep dive on Logality, an application I authored because of the requirements that I had at a very high, at a very demanding security-wise business. So with Logality is a versatile and extensible logger for Node.js. What does it do differently? Well, it prints log messages naturally. That's a standard thing. But aside from that, it can extend the logging schema to fit your needs. It has built-in or overridable serializers. I'm going to see exactly what those are. You can also have custom serializers. It supports middleware like Express does, like true middleware, and you can have multiple middleware where you can transform the log, or you can perform different actions. So, and again, we're going to see this in more detail. Logality enables full manipulation of the output, so you can rewrite the entire schema to fit your needs. Remember, that is a requirement that all systems log with the same schema. And that is what is the case right here. It supports asynchronous operation, which is a unique feature of Logality, and we're going to see why this is powerful and very useful. And Logality can also be used on open source libraries and composed on the root project, which is something that as an open source contributor I have suffered with for a very long time, and going to see why. And Logality also has some helping features that automatically detects the module, file name, and path that the log originated from. So let's see an expanded log of Logality. So you can see the level is expressed both as a string and as a number. They both have their use cases, and they are both important to exist. You have the message here, and it's either an event or a context that's going to be populated depending on what triggered and what the data is of the logger, of the log that is being produced. And as you can see here, we have the application name, we have the source where this log originated from, and system information is automatically also populated. All of this is automatically detected by Logality for you. You don't have to do anything. Previously, that was a JSON log expanded. This is the pretty print output. The logging level uses the syslog RFC system for severity levels. So we start from debug, info notice, up to emergency. Pretty straightforward. And this is how, this is the basic signature of Logality. So you have the Logality instance, and then the methods are based on the severity of the log. So this, in this case, that's info. The first argument is the message, and the second argument is any data you want to pass through. This is basically the metadata. And here is where serializers kick in. And what serializers do is that they look for a specific key, like the user key, and then they take the value of that key, which is the UDO in this instance, which is initials for user data object, and serializes it in a way that that makes sense for logging. So, for instance, this is a built-in serializer, and this is a user serializer. Whenever you input a user object, a user key with an object on the built-in serializer, this is what it will do. It will extract the ID and the email. And there are a couple more built-in serializers. You have a serializer for JavaScript errors. So if you pass an exception, Logality will automatically break it out into name, message, and then it will give you a very nice stack trace that is serialized without new lines. And finally, there is the Express serializer, where you pass the request object of Express, and you get some very nice information out of that already out of the box. You can have your own custom serializers. Say you are an e-shop, e-commerce website, and you have an order. And naturally, all of these objects are, their schema is standardized, and that's the whole convention here, that the order object is going to have the same schema all the time, and it should throughout your application. So this is serializing the order object. So we're being more explicit here. This is an order ID, so we take the ID. This is the SKU ID, so we take the SKU. We can perform transformations, like we can have multiplication between the fields. We can do pretty much anything. This is plain JavaScript here. So the next time you log anything and you pass an order item under the order key, this serializer is going to run and properly format the object for you. Now, you are also free to overwrite the built-in serializers. So if your user data object doesn't have ID and email, but it has different names, that's totally okay. In this particular example, we are adding a first name and the last name on top of the ID and the email. So whenever we pass the user object, this is how it gets serialized. Now let's look into middleware. And as I've said before, middleware are a very powerful feature of Logality. It allows you to interject business logic in the logging lifecycle. So the usage is pretty straightforward. You have a use function and then your callback. The callback receives one argument, which is the log context. And the log context is the entire log message represented in a native JS object, which is mutable. So you can delete certain fields, you can change them, shift them, you can do whatever you want basically with the log message before it goes downstream to the output functions. And here is where Logality really excels at, which is it has this unique feature that with a single switch during instantiation of Logality, you can make it operate asynchronously. And that means that all of the middleware are operating asynchronously. And that enables some very, very interesting applications where you can now start distributing your log messages to multiple endpoints. So for instance, you can see here that we perform a database write of the log. And for instance, there could be a conditional here checking for a Boolean, the audit Boolean that we talked about before. And if the audit Boolean is true, then, I want you to write this on the database as well. And what this may be is up to you again. This is just, a showcase. Or if it's a security kind of log, then I need you to send that log on my Slack channel as well. So you can have any sort of business logic here interjecting into your log messages. And remember that these are very nicely formatted messages as we have serialized them in the previous step, right? Serializers come before middleware in the life cycle of the log. Naturally, that means that you're going to have to invoke all of log messages with the await. Yeah, you're going to have to, because they execute asynchronously, it's required that you await for them. The keyword is await to make sure that everything executes properly. And last but not least is that you can interject on the master output. So this is how Logality is instantiated. We require the library right here, and then we get an instance which accepts a single argument, an object of configurations. We pass the app name. We say whether we want a pretty print or not. We say whether this instance is asynchronous or not. We just saw the example of asynchronous. And then we can define and override the output. And basically what happens here is that we are overriding, because as long as we are not returning the log context from this function, Logality will not continue any further action. If we return the log context in this function, then Logality would proceed and use its own output functions. But now, since we don't do that, Logality will take no further action. Thus, this is a signal to Logality that do not log this, we've taken care of that, and you don't need to bother yourself with outputting anything. And that's the last feature that I talked to you about, which is Logality can be used in libraries. So this is a third-party library. Imagine this is Mongoose or this is Sequelize that you're requiring, and Sequelize then exposes the Logality instance. which you pipe to your own instance. And then with the use of middleware, as we saw, you can intercept the log messages coming from Mongoose or SQLize and apply whatever business logic makes sense to you. This has been a very thorny issue because, you know, major libraries require some sort of logging so that you know and understand what's going on. And the only way for logging libraries to pass information upstream to the application requiring them is through errors. And that is a very brute method, right? So that's all about Logality. Let's have a quick look at how Logality compares to all the other popular libraries out there. And I've chosen 3 of the most popular ones: Winston, with 6 million downloads per week; Pinot. Pinot has been hosted a lot of times by this meetup, and probably you're very familiar with it. And Bunyan was one of the classic loggers of Node.js in the past. So all of the libraries output as JSON, which is very important and very nice. All of them pretty print except Bunyan, which requires another library to transform the JSON output and pretty print it, so it's not included. Custom log levels is not supported by Logality and Bunyan, but I guess if you're really determined with custom log levels, you can intercept the master output and transpose Logality's levels into whatever you see fit. Serializers. Winston doesn't have serializers. Bunyan does. Pinot kind of has. It gets a check mark because it's got the same concept. Middleware. Logality has middleware, as we've seen. Winston has middleware, albeit in a very complicated way. That's a general remark around Winston, is that it's fairly complicated as a library to work with. Bunyan doesn't have middleware, and Pinot barely has middleware in the sense that it only supports a single middleware, and so you cannot have multiple middleware with Pinot. Mutating JSON schema. We've seen why this is important and why this is a core requirement for the logging libraries, because you shouldn't get married with the schema that the authors propose, right? Because then there's another logging library on Go that has a different schema, and you need to have parity between the schemas. So that's only supported by Winston and Logality. Output destination, you can choose an output destination on all of the libraries. Mutate the output, the master output function that we talked about. This is only possible on Winston and Logality. Asynchronous operation, as we've seen, is only available with Logality. Automatic file name detection, again, it's a Logality only feature. Speed optimization is clearly, Pinot is the winner here. That's the entire value prop of Pinot, and the reason why it was built around. It's a very fast logger. That's that's the reason why you use Pinot. And library composability is only available on Logality. All the other libraries have a system of producing child loggers, which only works on the same application. So to recap, logging is important for debugging and troubleshooting, security and auditing. It excels there. Performance monitoring, less so, but it can help. Common schema and appropriate logs can make all the difference in your entire infrastructure. And you have many choices for a logger. Choose what is appropriate for you, not what is more shinier. And that's all. Since I don't have a live crowd, I'm going to upload it myself. Thank you very much. And I am open to any questions that you might have. Aris?
Yeah, that last slide, because I've seen it before, for me is the key slide from the whole talk, where people can see why it's so important to use and I mean people they have to get a coffee or a beer for Thanos because he helps them to find out what is the best solution. In Greece, probably they have to get him a coffee because that's what we drink most of the time. But yeah, I mean that was a good talk. Let's see if there are any questions on YouTube. Um, while we're waiting, how did you come up with building this, building Logality and?
So the requirements were from the security aware business that I was working at, and we needed two requirements that basically could not be done by any package that I completely transform the schema, so it meets a certain it meets a certain schema that we had in the infrastructure that would work with all of the stacks across the infrastructure. And the other requirement was being able to flag and store audit log trails as they happen. So you have such well-structured information, it made sense to leverage that in creating the audit logs versus building a different service that basically did the same thing, serialized information and stored in a different data store.
Okay, and I know probably it's going to be a bit of repetition, but it's good to know how was the thought of using these, creating something from scratch, rather than using something that already existing. How did you take that decision? What was
Right.
that chart that you saw us with all the different systems that they didn't have something that made you build something from scratch?
Yeah, I mean, that goes back to the matrix that I had with features. And the reality is that Logality wasn't built in a day. So it started like 4 years ago as a very simple way to log a schema and provide a pipe to save the data on a different endpoint as well. It was very, very custom made and very coupled, and it took the course of 4 years to make it into a library where everything is decoupled and it's more of a generic use rather than verticalized, structured only for our use case.
Okay, so it can be used now much easier than all the other different solutions like Pin and the other ones that you.
Well, I wouldn't say easier, but it's like, it's more of a generic logger right now rather than a specific logger to our particular needs. And it just so happens that out of that, some interesting features came out, like the middleware, where you can have multiple middleware intercepting the life cycle of a log, and the asynchronous operation that allows you to pipe the log messages through different mediums like Slack or different data store or anything else.
As well. No, that's
Yes.
really good feature. No, that's very good. And how have you seen the usage so far? How have they been using it a lot?
Well,
some projects that have it?
To be frank, I'm not monitoring it, but we can check it right now.
Yeah. It will be good for people to know where it's being used in some different kind of cases.
I have an open source library that is linked from Logality that uses Logality. And so that people can see how it's actually used in production. The usage is rather small, but it's not something that I've been actively promoting. As I see now on NPM, it is at 55 downloads per week.
Oh, that's very
So
good.
very small, but with the help of your meetup, maybe we can raise that.
And you're looking for contributors and people to help you to improve. Are there anything that in particular that you are looking in terms of help?
I am looking. I'm not looking for any help in terms of development. I'm mostly looking for participation in the project, people using it, people coming out with feature requests or issues, and moving the library forward.
Okay, no, that's great. It's good to know. Okay, yeah. So yeah, so it can be used for both backend and front end, right? Because you said, is it?
I believe so. I haven't really tested it on the front end, but I intend on doing that fairly soon. And if anything needs to be worked out, I will do it on the spot.
Okay, that's perfect. There are no questions on the on YouTube, but we will be checking the feed because people can watch it after this when they have time.
Yep.
Uh,
Yeah, I will check it too and answer any questions on the comments.
Perfect. Thank you very much, Tano, as always.
Thank you. Thank you for the opportunity.
And we're very excited to have you every time. And we look forward to have you in the future as well. Thank you very much.
Thank you. Have a great day.
You too.